Okay, so the next test, you follow me and write it here. Your test 5.3G, I think. Okay, this will include your under your exercise 5.3 question B. I think 11 and 12, two of them, 11 and 12. We'll find this on textbook page 118. So write it likewise along with me and then follow me. Start with B11. Okay, and let me read the question for us. If the sum of the first n terms of an AP is 4n minus n squared, so here just write what is given to us. Sum of n terms means Sn, right? Is 4n minus n squared. So this is given to us. Which, after that, which is the first term? That means first term A1. That is S1 means sum of one term, right? So first term is A1, which is sum of one terms. First term and sum of one term is the same, right? The first term is only one term, so sum of one term is the same as that. So we have to find out. Then as we read the question on, what is the sum of the first two terms? So sum of n terms is Sn, so sum of two terms, first two term will be S2. That's also a question mark that we need to know. What is the second term? Second term means A2. First term is A1, second term A2, third term A3, fifth term A5. So we know the logic behind writing this, right? What is the second term? Similarly, find the third term. So third term A3, also A2, also A3, also we have to find the 10th and the nth term, comma. Then we have to find the 10th and the nth term. So A10 is the 10th term and the nth term. So these are the things that we need to find out. All these question marks: A1, S2, A2, A3, A10, and AN. That's what the question is saying. So let us start with the first one. Therefore, the first term, A1, which is actually S1, we'll use this advantage of S1 and compare it with what is given. Sn is 4n minus n squared. So S1 will be 4 into 1, because in this case S1, n is 1. So in place of n, I'm putting 1. Minus n is 1, so 1 square. So the 4 ones are 4, minus 1 ones are 1. 4 minus 1 is 3. So the first term value is 3. That we have found out this one already. Then we have to find sum of two terms. So sum of two terms. I want you to follow this carefully. Now sum of two terms will be there. Sum of two terms will be sum of two terms will be the first term plus the second term, which is in effect sum of two terms is okay, so sum of two terms S2, sum of n terms is 4n minus n squared. So sum of two terms, following the logic of what is given here, Sn, so n is now 2, so 4 into 2 minus n is 2, so n squared means 2 squared. So we are taking advantage of this given value of sum of n terms, so which is equal to 4 2s are 8 here, and minus 2 2s are 4, so 8 minus 4 is 4. So S2, I think it's the same as the book answer. Yes. So that also found out. Then A2, I want you to follow this. So second term, A2 will be sum of two terms, because A1 plus A2 is the sum of the two terms. A2 is A1 plus A2. Oh, sorry. S2, sum of the two terms is the first term plus second term. So I want you to follow what the logic behind we doing this. A2 will be sum of both the terms A1 and A2 minus sum of the one term, the first term. Sum of the A1 plus A2 minus S1 means sum of the first term. So these two will cancel and give you A2. So sum of two terms, A1 plus A2, minus sum of the first term. S1 means sum of the one term or first term, which is A1. So minus A1 plus A1, leaving you A2. So likewise, don't write this, but I'll follow this. So if you want to find the fifth term, it will be sum of whatever is here, all the five terms, minus sum of the four terms, preceding fifth term, A5. It means A1 plus A2 plus A3 plus A4. Sum of all the five terms minus sum of the four terms preceding the fifth term will be the value of the fifth term. I hope you're following the logic, right? So here now, that will give you here sum of two terms is following this formula Sn equal to 4n minus n square. Sn is 4n minus n square, so S2 will be, in that case, n will be 2, so 4 into following this formula, n means 1, n is 2 here, see, 2 minus n square, so 2 square. So this is the value of S2 minus S1 will be, Sn is 4n minus n square, so S1 will be 4 into 1, because n is 1 now, minus n square means 1 square, because n is 1, so that is the answer. So this will be 4 2s are 8 minus 2 2s are 4, minus 4 1s are 4 minus 1 1s are 1. So 8 minus 4 is 4, minus, here 4 minus 1 is plus 3. So you're going to get here 4, remove the bracket, minus in the plus, 4 minus 3 is 1. So the second term A2 is 1. Same as book answer, yes. Then we'll go to A3. So let us do A3 likewise. Just as A2 is sum of the first two terms minus sum of one term, the first term. So A3 will be sum of three terms, S3, minus sum of the two terms preceding the third term. So that will be S2 minus S1. So A3 will be S3 minus S2. So if we follow this formula, S3 using this, Sn, 4 into n now is 3 minus n square, so 3 square. So this is the value for S3 minus S2 will be, likewise using this formula, 4 into 2, n is 2 now, minus n square, so here 2 square. So we're going to get here equal to 4 3s are 12, right? And then minus 3 3s are 9, okay. And here minus, so you just write the minus. Then 4 2s are 8, minus 2 2s are, 2 square means 2 2s are 4. 12 minus 9 is plus 3, and then minus 8 minus 4 is simple 4. So 3 minus in the plus is minus, so minus 4. So minus 4, bigger absolute value, plus 3 is subtraction, 4 minus 3, 1. Bigger one minus of minus 4 plus 3 is, or plus 3 minus 4, whatever it is, in other words, is minus 1. So the third term is minus 1. A3 value is minus 1. Yes, same as textbook answer. Similarly, let's go to a 10th value will be sum of the 10 terms, all the 10 terms, minus sum of all the terms up to the 9th term. Just like A3 is S3 minus S2. So A10 will be S10 minus S9. Sum of all the terms up to the 10th term minus sum of all the terms up to the 9th term is leaving behind the 10th term value, right? Common sense also tells us that. So following this formula, S10, Sn equal to 4 into n is now 10 minus 10 square. This is the value for S10 minus 4 into 9, because your n is now 9, minus 9 square. 9 square. Because n square here, n is 9. Leaves you 4 10s are 40, minus 10 10s are 100, minus 4 9s are 36. 9 square is 9 into 9, 81. Leaving you here I think a simple case of here this one minus 100 plus 40 subtraction 60 minus 60 is leaving you behind, and then here minus, and here bigger absolute value is minus 81, smaller one is plus 36 here, plus minus. So subtraction 11 minus 6 is 5. 1 taken from 8 to make 11, so only 7 left. 7 minus 3 is 4. Bigger one minus, so here also minus. So this 2 will give you minus 45. So that leaves you plus into minus is minus 60. Minus into minus is plus 45. So minus 60 and plus 45 is our result. Plus 45. Subtraction because minus plus 10 minus 5, 5. 1 taken to make 10. Here's only 5, so left 5 minus 4 is 1. Bigger absolute value minus, so it's going to be minus 15. Minus 60 plus 45 in other words is minus 15. So the 10th term value at 10 is minus 15. Same or? Yes, same as textbook answer. So we have found out A1, S2, A2, A3, as you can see here, A3 value minus 1, and then A10 value. Finally, we're left to find AN. So let us do that. So let us write down. And AN, the nth term value will be, following this pattern, sum of all the n terms plus sum of all the terms just before nth term. So here n minus 1. Just like A3, just as you've done here, is S3, sum of all the 3 terms minus sum of all the 2 terms before the third term. So AN value will be sum of all the n terms minus sum of all the terms just preceding nth term, which is n minus 1. So Sn will be here following this same formula, 4n minus n square. Sn exactly this minus Sn minus 1 following this formula will be 4 into your n is now n minus 1 in this case, then here n square, so minus, and then n square, so our n is n minus 1 in this case Sn minus 1, so the whole thing square. So this is the value for Sn, as you can see. This is the value for Sn minus 1 following the pattern of this given value of Sn. Okay, you can follow that, right? Quite simple. So it's a matter of solving it carefully. So that's going to give you here, just give it for now, 4n minus n square minus 4 into n, 4n plus and minus, 4 ones are 4. So up to here done. Now here, just keep it, don't touch this bracket. Then the famous formula, which is the simple formula, a minus b whole square is equal to a squared plus b squared minus 2ab, or you can also write a squared minus 2ab plus b squared. These two expressions are one and the same formula, right? A minus b whole square, if you follow the first pattern, then it'll be a squared plus b is 1, so 1 squared minus 2 into a is n into b is 1. So a minus b whole square is a squared plus b squared minus 2 into a into b, 1. Close the bracket. We are following this formula, a squared plus b squared minus 2ab for a minus b whole square. So just proceed. 4n minus n square. Yeah, okay, I forgot to put it here. Then here minus. Let's deal with this one first. Minus 4n minus 4. Now minus bracket n square. Then here plus 1 square means 1 into 1, which is 1, minus 2 into n into 1 is 2n. So that is it. So this is n square, 1 square 1, 2 into n into 1, 2n. Next, 4n minus n square. Do it patiently. 4n minus 4. Now we can remove this bracket by multiplying the outside to the inside. So minus in the plus, minus n square. Minus in the plus, minus 1. Minus in the minus is plus 2n. So since you multiply the outside to all these three terms inside this bracket, first bracket will remove and then the square bracket is still there. Now I think we can deal with this part here. See, 4n minus n square minus, then here n, here also n, so plus 4n plus 2n are like terms, so plus 4 and plus 2 is, both plus means add, so plus 6, so this 2 will give you plus 6n, and minus 4 minus 1. Minus 4 minus 1 means both minus, so add 5 plus 1, 4 plus 1, 5, both minus means minus. So minus 4 minus 1 is minus 5. Then only this is the long term left behind. All done, tick, tick, tick. So this is the one we're getting. Then we can now open this bracket. Plus into plus is plus 4n. Plus into minus is minus n square. Then we can remove this bracket also by multiplying the outside to the inside three terms again. Minus into plus is minus 6n. Minus into minus is plus 5. Minus into minus is plus n square. Having done that, now you can see here minus n square and plus n square will make 0. Just like plus 4 minus 4 is 0, so plus n square minus n square is 0. So this is gone. Then plus 4n plus 6n, let's try. Plus 6 plus 4 is plus, or both plus or plus 10. So plus 4n plus 6n. No, I made a mistake. Minus 6n. See here, minus 6n plus 4n is minus 6 bigger plus 4 smaller, so subtraction 4 minus 6 minus 4, 2 bigger 1 minus, so this is the one. So plus 4n minus 6n you're going to get equal to minus 2n. So this is also done. Then here only left is plus 5, so you write there plus 5. So that's our answer. But usually we prefer to write the plus term first, so plus 5 bring it front. And this minus 2n can go to the second place. You can stop here also, but you can write it like this. So the sum of the nth term value is 5 minus 2n, or minus 2 plus 5 is the same. So that's the same as the textbook answer, yes. So that completes number 11. Let us go to 12, the last question. I hope you're getting it. Okay. Question B12. Let me read the question for us. Find the sum of the first 40 positive integers divisible by 6. So just write here. The first 40 positive. Remember, it's positive, not negative. Positive integers divisible by 6r. Now, the first positive integer divisible by 6 is 6. So 6 by 6. So it is 6, comma, and 6 2s are 12. 6 3s are 18. The next positive minus 6 is also divisible by 6, but it's a negative integer. First positive integer divisible by 6 is itself 6. Then next is 6 2s are 12, 6 3s are 18. 18 divisible by 6. 12 by 6, 3s are 18. 6 3s are 18, 6 2s are 12. So the next one, comma, like that it goes. And then up to the 40th term, right? Up to 40 terms. Up to 40 terms, because they're saying first 40 positive integer, 40 terms. So 1, 2, 3, 3 and 37 more terms to make for total 40 terms, which is definitely an arithmetic progression. How do we know whether a series of numbers is AP or not. The only criteria is they must have common difference. So here see 12 minus 6, 6. Then 18 minus 12, 6 again. So the difference is common. So this definitely AP. With the only condition for AP is it must have common difference, and we can clearly see it has common difference. Common difference D equal to 6. See here. Or we can just show once. A2 minus A1, A2 minus A1, A1, A2, A3, A2 minus A1 is 6, A3 minus A2 is also 18 minus 12, showing that throughout the pattern the difference is common, means same difference. So this way, since they have a common difference, we are saying it's an AP. Now if it's an AP, then let us sort out here, and common difference D, then the first term A is 6, okay, and then number of terms is denoted by n. 40 positive integer means there are 40 terms, so total number of terms 40. Therefore, go back to question, sum of the first 40 positive integers. So required sum or sum of the first 40 positive integers divisible by 6. Sum of the first 40 positive integers divisible by 6. So sum of all the 40 means sum S40. That's the one. S40 is given below here. So S40, sum of all the first 40 positive integers would be formula using this here. N is 40, so 40 by 2, n by 2 into 2a plus n is 40 minus 1, n minus 1 into d. So we can write it once like that. You cancel these 2 ones are 2, 2 2s are 4, 0. So 20 by 1 means 20. Next here, carefully do it. 2 into the first term value a is 6. 40 minus 1 is 39. Into the d value, common difference is here 6. So you can keep it like that. So that gives you 20. 2 6 are 12 into 12 plus 39 multiplied to 6. 6 9s are 54. 5 in hand. 6 3s are 18. 19, 20, 21, 22, 23. So 234. When we multiply these two, we're getting 234. As we proceed, you're going to get equal to 20 into 234 plus 12. So 234 plus 12. When we do this, you're going to get 6, 4, 2. 234 plus 12. 246. Let's use the 2 to multiply this. 2 6 are 12. 1 in hand. 2 4s are 8 plus 1 9. 2 2s are 4. So 2 into 246 is 492, and this 0 you can just put it at the back. So sum of the first 40 positive integers divisible by 6 is 4920. Is the same as textbook answer, I hope. Yes, so that concludes the part for test 5.3G. I hope you got it right. Okay.